right, so lesson 11, we are now going to be factoring our expressions. And remember, expressions, your math problems. Factoring, they are what's in a multiplication problem. So typically, they are your numbers that are in your multiplication problem. They're going to look a little bit different today simply because, well, we've got our variables that are playing with us. And remember, your variables are your letters. So we are actually going to skip on down, and we're going to start off with letter E right here. And we're going to make a little trip down memory lane, as it says in 5th grade. All right, you use similar reasoning to solve problems. What's the name of the property that's used to say that this is the same as this? So first of all, we want to get rid of the x's there and how we're used to writing things out. So we do have our 1. We've got this guy, all right, and then the other guy we are looking at is the fact of 2 times 5 plus 2 times 3. This is our distributive property. Get used to this guy. This is also another person that does not leave your side for the rest of your mathematical careers. So it is something that we will see a lot of. The big thing is this. We've been dealing with numbers all the time. So order of operations would say, hey, we can do what's inside the parentheses first, and we can do 5 plus 3 and get 8, and then a number up against parentheses means multiply, so 2 times 8 is 16. The other thing that we're seeing here is that, well, you could, because a number's up against parentheses, and there's 2 people inside there, you could actually multiply to both of them. So 2 times 5, which is 10, and then 2 times 3, which is 6. 10 plus 6, it does give us 16 as well. So it's just one of those things of where it's like, well, can't I just use order of operations? Yes, you can. But we are going to have to use our distributive property because we're not always going to be able to add our numbers together. So let's skip on down to example number 3, and this is what we're after. We want to use the greatest common factor and the distributive property to write equivalent expressions. So the main thing is this. Who is the greatest common factor between 3f and 3g? And at first, we always look for numbers. That's the big thing. So we're looking at the 3, and we're looking at the other 3. What's the biggest number that goes into 3 and into 3? Well, yeah, it's 3. So that's who's going to go on the outside. And the big thing is this. You've got 3f plus 3g. Your greatest common factor is 3. So we're going to open up our parentheses. What do you multiply 3 by to get to 3f? Well, 3 times f is 3f plus, and then 3 times what is 3g? Well, 3 times g is 3g. So our official answer is 3 times f plus g. Now, again, we're going to get to the point where you're going to be kind of like, well, do I have to write that all out? No, you'll be able to jump straight to the answer, but it is a comfort level. We want to show you where things are coming from. This builds through a lot of things. I'm not really going to worry about it. We're just more of just the straight up factoring that we're going to see. They're going to ask you to do a bunch of kind of different questions, and right now, I think it's going to be much more straightforward if we just kind of jump right to it. So, so the big thing is this: is what is the greatest common factor? Well, what's the biggest number that goes into 6 and goes into 9? Well, it's what? Yeah, it's 3. So the whole idea is that we got 6x plus 9y. 3 is the biggest number. So 3 times what is 6x? So 3 times what is 6? Well, 2. So it's 2x, and check, is 3 times 2x equal to 6x? It is. Bring down your addition sign. 3 times what is 9y? So in other words, 3 times what is 9? Well, that's 3. So it is 3 times 2x plus 3y. So there is our official answer that we've got. Again, we're rewriting here. That's what we're doing. We're not solving anything. And this is the big adjustment that you're going to have to be making is you guys are so used to solving. And now it's, no, we are rewriting things. Look what happens in 3. We have 3c and we have 11c. Check the 3, check the 11. No one fits into both of them. But what's in common? We do have a variable that's in common. So we do have the letter C that is there. So as we take out the C, because that's what's in common, and we'll put our 3C plus 11 up here. C times what is 3C? Well, that's 3. C times 3 is, and I know we write it out differently, but if we ask what is C times 3, we do write out as 3C. And then plus, and then C times, oops, that should be 11C up there. C times what is 11C? Well, all right, C times 11 is 11C. So there we've done our factoring. Now you might be asking, can we do the 3 plus 11? We certainly can, but they did ask us to factor. We do want our two factors. And this is where, again, we talked about it being a little bit different. One of your factors here is 3. The other factor is 2x plus 3y. All of that's a factor. We're just used to 5 times 4. Your factors are 5 and 4. Now our factors are 3 and f plus g. So again, variables are coming out to play here. So we do want to make kind of use of them there. So let's jump on to the next one. Greatest common factor between 24 and 8. You should be saying, yep, 8. So we put our 8 down, open up our parentheses. 8 times what is 24b? So 8 times 3b, because 8 times 3 is 24, plus, and then 8 times what is 8? Well, 8 times 1. So there we go. So that's kind of how we can get away with what's there. All right, so let's just keep on going down there. Apply the distributive property. So to write equivalent expressions. Again, different directions, you're pretty much going to see that phrase factor. And the word factor means that you're going to have to use the GCF. All right, and you're going to have to use the distributive property that's there. Okay, so let's try a few of these and see what you think. Who's the greatest common factor between 7x and 7y? Well, you should have 7. So 7 times what is 7x? Well, 7 times x is 7x. Plus, and then 7 times what is 7y? Well, 7 times, well, y is 7y. All right, let's jump on down to letter C. And this is where things become a little bit more interesting because our numbers are just a little bit larger. I got 18 and I got 42. Remember, we need greatest common factor. Greatest common factor. So we could, if we're unsure about it, go back and use our technique to find greatest common factor. And that was our slide technique. So who fits into 18 and into 42? Well, 2 does. 2 fits into 18 9 times. 2 fits into 42, well, 21 times. Who fits into 9 and 21? 3 does. 3 fits into 9 3 times. 3 fits into 21 7 times. Who fits into 3 and 7? Well, no one does. So this is where we would multiply our outside numbers. So 2 times 3 gives you 6. So your greatest common factor is 6. Now you might have been saying, oh, come on, 18, 42. I knew that was 6. That's fine. That's fine. This is only if you're kind of going, I can't come up with anything. Well, then we've got something that we can use there. So your greatest common factor is 6. 6 times what is 18m? You should be saying 3m. Because 6 times 3 is 18. Plus 6 times what is 42n? Well, 6 times 7 is 42. So it is your 7n that we're looking at. Let's skip over to E. Look at 11, look at 15. No one fits into both of them. But I do have a variable that's in common. So I do pull that f out. F times what is 11f? Well, 11. F times what is 15f? Well, 15. And there we go. All right. Let's take a peek and let's go to letter G. Okay. Who's in common? 55 and 11. The greatest common factor is? Yeah, 11. All right. So 11 times what is 55m? We say 5m. And 11 times what is 11? Well, it is 1. So we got to make sure we have the 1 that's there. It's kind of like a placeholder that we've got. And there we go. There is our answer. We've got a lot more that kind of goes through this. And the main thing that we're looking at here is just to show you that it ends up working with your variables. So let's come down over here and let's watch what happens. we're going to do letter C here. They just want to show you that it works even when you use your distributor property. If you use your distributor property 2 times 7x, well, that is 14x. 2 times 1, well, that is 2. So the whole idea is that when you plug them in, you still should get the same answers, even though you're solving them a little bit differently. So 14 times 10 plus 2, so that's 140 plus 2, 142. Even over here, 2 times 7 times 10 plus 1. Order of operations go inside your parentheses. 7 times 1 is 70. 70 plus 1 is 71. 2 times 71, it's still 142. So again, they're just showing you that, listen, distributive property, it works. It's an alternate way of doing it. It's something that you're going to use a lot. But yeah, for right now, it doesn't, it's awkward because you guys aren't used to seeing it. But it is something that's going to spend a lot of time with it. So fill in the blanks here. Fill in the missing value that goes along with it. I'm going to have you finish this, and you need to go on back, and you need to finish these particular exercises as well. All right, we did some of them, but you do need to finish. So we want to finish this particular page, and I do want you to go ahead and finish the bottom section as well too. Just that right there. Fill in the missing blanks. All right, sound good? Can you handle that? I think you can.